It's so good to see so many of you here. And what I'm going to talk about today are just a couple of Python projects that you might find interesting, you may not, to help you in various bits of your work or to help planetary science users that you might work with. So I'm going to talk about 3 libraries. The first is the one I'm going to share my browser here. Let's see if I can manage to do that, failing terribly. So the first project is called the kalasiris library. It's a mouthful. But what it is, and also, I'm going to try and make these presentations purely from my documentation. We'll see how good my documentation is. So the kalasiris library is a Python library for calling ISIS programs. So you may be familiar if you've ever needed to do this before. There was a library called PySys, which used to do that very same thing. It was written for primarily in Python 2, and was a very thick wrapper around the ISIS calls. Kalasiris is written to be a lot of a lighter touch around the sub-process call in Python. The other thing is that when I wrote kalasiris, it was very early on in my how do I use Python as a scientist, and I knew that there were complicated ways to install different Python packages and programs. Right? There's pip and there's conda and there's all these other things. And at the time, I didn't know anything about them at all. And so one of my goals for writing this library was to be able to provide the essence of this functionality in a single Python file that you could just copy and drop into any project that you were working on, which I managed to succeed in. So the primary library, the piece of this library that does all the work is in the primary kalasiris file here, and I will show it to you simply because I am proud of it. So if you just take this one file and drop it in any of your folders, then you can call functions on kalasiris. As you can see, this file is about 156 lines long, and it's about half documentation. But ultimately, it just lightly wraps via the Python subprocess call, calls out to the ISIS program. So you need a fully functioning ISIS on your machine somewhere to be able to use this library. But when you do, you can do things like this. So you can import, right? You say from kalasiris import camdamap, right? And so now you can define something that's called fromcube and toCube. These have to be paths somewhere in your machine, and then you can run camdamap like this in Python, and it'll allow, right? In Python, it'll make the subprocess call, and it'll run camdamap for you. And then at this place, there will be something that's been camdamapped. Okay, so it's pretty straightforward. It acts, like I said, a lot like PySys if you've used it like that before. Kalasiris has some additional bits and pieces if you do install the whole library, and it is available via Conda Forge. So if you're familiar with using Conda because you've installed ISIS that way, you can make a new environment, a new Conda environment that installs Kalasiris. You'll have to make sure to link it across to your ISIS program as well so that it knows how to find it. But when you do, you can run all kinds of great, all the stuff you need to run ISIS programs with from within Python. Now, I was talking with a scientist, and I said, well, he was talking about how he was using Python to run ISIS programs, and I told him about this library that I was writing. He was like, yeah, but I don't want to do that. And I said, okay, that's great. You may not need a deep library like this, and this is not really all that deep, to get a handle on just running sub-process calls out to ISIS. And if you have code that's working just fine now, then you should keep using it. But one of the other things that kalasiris provides is a few other little pieces that help you do things maybe faster, right? So let me go through a few of them now. So we provide a couple of other pieces that deal with kind of standard ISIS bits and pieces. So there is a histogram class that knows how to read one of ISIS's histogram files and provides both dict-like and list-like access to the contents of that histogram file. And this is where I will jump over to the documentation that we have on Read the Docs. There's good stuff here, but I'll just go into this and talk about some of these options. So the histogram module here, right? So an ISIS histogram file is a text file. It looks like this. It's got some header stuff, and then it's got the lines of your histogram. If you use the histogram module, then you can get access to it as key value pairs and then as a list of lists down here, and be able to get at it. Other bits and pieces, there are these things called k-functions, which are the way that I want ISIS programs to work. They don't always work like that, right? So for example, get key, the ISIS get key command requires you to have, right, the name, and you have to say group name equal instrument and keyword equal instrument ID. And if you run it the standard way, right, so the kalasiris library, when it runs get key, is going to return you this completed process ID, and then you have to say, give me the standard out from that and strip it. But really, like 99% of the time when you run get key, you just want to say file, group, keyword, give me the thing, right? And so the getKey.k function and these other .k functions kind of make these things work the way I would expect them to work. They may not be the way you expect them to work, but there's room for improvement for sure. Finally, in this speedy intro to this library, I'll tell you about the from list module. So in ISIS, you often have to, ISIS for whatever reason can't take multiple arguments, right? So generally it has this thing called a from list. So you have to, if you need to run something on a bunch of ISIS cubes at a time, you first have to make a text file and, you know, one path per line in the text file. But instead, to help that along within kalasiris, I built this context manager for from lists, right? So you can say this. So you can say with from list temp, and you can give it a list of your path names as F, and then you can run any ISIS program like Qubit or anything else and give it the name of this within this with statement, if you're familiar with using, you know, with statements to open files or other things. And under the hood, what kalasiris does is it takes this array, it makes a temporary file, it makes it available via this F variable that you can then use. And then once you exit the with statement, it takes care of deleting it for you if you don't need it anymore. That's kind of handy. So ultimately, if you find yourself doing a lot of calling ISIS from within Python for various things, you might find kalasiris to be a useful library. Okay, so now that was my brief but hopefully informative trip through the kalasiris library. I'm going to stop sharing that and talk about my next Python project. I've been doing a lot of Python programming this year. And the next project I'm going to talk about is, bring that up so I can see it, is PVL. So there's this Python PVL library that's existed for some time, written by W. Tolson, who is his, oh, we need to fix that. That's kind of broken. I wonder what happened there. I will go to the docs as well. PVL has been around for a long time, but this last year I embarked on a rewrite of PVL because the PVL library didn't handle as many kinds of PVL. There are a lot of bugs in there, or there's also just a lot of different kinds of PVL that people have out there, and being able to ingest all of it was a bit of a challenge. So ultimately, if you've used the PVL library before, the new version is not available in CondaForge yet. It hasn't been pushed to Tippy yet. The documentation is updated with this 1.0 alpha version, and that's what I'll be talking about. The 0.030 is the version that's still on CondaForge. But if you do a lot of work with the PVL library, then you might want to try and check out this version from GitHub and see if it works for you. We'd certainly like to see if things are broken. But ultimately, it's the same great PVL library that you've always had. PVL load and PVL dumps. And dumps are the functions that you're going to use to bring in and export PVL text. The advantage is that now the PVL library consumes more different flavors of PVL text than ever before. And also, more importantly, now we've codified the different versions of PVL. You may not know this, right? Random users of PVL don't know that there are several quote unquote dialects, if you will, of PVL text. So there's the actual parameter value specification itself, but people don't usually mean that when they say PVL in planetary science. They're usually referring to the PDS-3 standard, which is itself built on the ODL language, which is a version of PVL, right? And on top of that, the ISIS software package doesn't use any of these standards, but has its own kind of quirks. So these are the four kind of flavors of PVL that actually exist. And the new version of the Python PVL library actually specifies all of these. So if you want to get specific about which version of PDS you're ingesting or writing out, you can do that. And so parsing PVL and writing PVL is kind of the same as always, but better. So PVL loads files. It takes files that are already open, right? If you've already opened them, you can PVL load it. If it's not open, that's fine too. We'll just load that file if you give us a file name. If it's a new Python path object, we'll take that too. So it really consumes a lot of the things and allows you to use it the way that you want to. You used to have to open it and provide the PVL load with a byte stream. You don't have to do that anymore. What other quick bits? So the other fun thing, so hopefully there's good documentation and you can understand that. One of the things that we added were these utility programs. So now there are, if you install PVL, the PVL library properly, you will get these two programs, PVL Translate and PVL Validate. PVL Translate works, if you're familiar with GDAL Translate, that's the user interface model that I worked it off of. But PVL Translate, if you have PVL text in one of these PVL formats or in JSON, you can, it reads PVL from the in file. I don't think it reads JSON. I'll have to go check. But it can write out any of these specific dialects or as JSON. And there's some examples of it doing that and the subtle vagaries for how the different PVL text is different. The other thing is there's this PVL Validate program. And PVL Validate, you can run it on one file. So here's an example of running it on one of the data files in the package itself. And it tells you of the different varieties, whether it can load it and whether it can encode it back out. So some of the text, due to the way that the PVL specification is written, sometimes PVL can read a particular specification, can consume some kinds of PVL text, but it prefers to write out a specific kind of PVL text. And so that's why there's both a load and an encodes check here. When it can't do that, it'll tell you that it can't load some text, does not load. And you can give it the -v flag, and it will tell you why it wasn't able to load it, right? In this case, it was expecting an aggregation block, an assignment statement, or an end statement, but found an equal sign where there shouldn't be one, et cetera. You can do that on one file. You can also run PVL Validate on a whole bunch of files like this, and it'll kind of give you this big matrix about all of these files that you loaded, whether it can read it, load it, and encode it or not. And again, with -v, it can show you where it failed. So if you've been a user of the PVL Python library before, we invite you to come and check out this new library and download it from Git and give it a spin around. We expect that this 1.0 alpha will get up onto CondaForge and Pippy so that you can download it quote unquote properly. And once we kick the tires enough, then we'll bump it to real 1.0. And that'll be very exciting. That'll be the first like big update to PVL in a couple of years. Finally, because I don't want to go too far over time, the last thing I'll talk about is, as I told you about, I've been writing a lot of Python this year. And one of the things that we wanted to try and manage was to reinvigorate something called the PlanetaryPy project. So this has been an organization on GitHub for a while. And Michael New, myself, Chase, Andrew Annex have tried to resurrect the PlanetaryPy project. We're in the process of doing that now. There's a very successful project in a similar vein called AstroPy. That's a really big Python package thing for astronomy, and we thought, oh, we could really reinvigorate PlanetaryPy and try and make that happen in planetary science. So that's what we're doing. There's nothing really happening yet. We're trying to figure out our charter and our code of conduct and try and figure out what the rules are for, as you can see, there are no core modules or affiliated modules yet. So we're still working out the rules for how someone would apply and how we would pull them in and all that stuff. But if you are interested in, if you've got a Python project that you think, oh, other people could benefit from this, keep an eye on this project, and hopefully you can submit those to us, and we'll kind of start collecting those or joining them into the main project. Hopefully we hope to make PlanetaryPy bigger and to collect more pieces that people can use, and so that not only if you're a developer can you submit things and then add things to the PlanetaryPy project, but also if you're a user, coming to the PlanetaryPy project might be a good first stop if you're trying to learn how to do things or get libraries and modules for Python. Okay, so that has been, I talk real fast, and I apologize for that, but I want to make sure to leave time for questions and also for us to have a wider discussion on this telecom before the end of the hour. So I'm happy to take questions about anything I talked about, or we can kind of go into the more general question and answer session.